Okay. Here we go. I don't know if it's going to work. I might just use this. So. We are going to be looking at quadratic inequalities today. We're going to graph them to show the solutions, and then we're going to solve them using like algebra and stuff too. Okay? So let's just jump right in. All right? There's not really too much to say here. I think you'll have some familiarity with this from before. So let's say we're going to graph y is greater than x squared plus 3x minus 4. Okay. Strange. Okay. So, when we go to graph, right, our graphing calculators can be super helpful for us here. We can also find our vertex using that vertex formula. In fact, I'll go ahead and use the vertex formula here, so we'll just do that. So vertex, okay, we'll find is x equals negative b over 2a. Okay, that is the front of the quadratic formula if you think about it, right? You have negative b plus or minus the square root all over 2a, so negative b over 2a is the front part of the quadratic formula. Okay. So what is our b in this problem? 3. So we'll have negative 3 over, and what is our a in this problem? It's 1, right? Yeah, so we'll have 2 times 1, which is going to be negative 3 halves. Okay? Or negative 1.5. Once we have the x coordinate, how can we find the matching y coordinate? What will we do? Once we have the x coordinate, how do we find that matching y coordinate? Plug it in. Yeah, plug it in. Exactly right. Yep. So we'll treat it like it's an equation, and we'll say y equals, and then we'll do negative 3 over 2 squared plus 3 times negative 3 over 2 minus 4. Okay, like that. Okay. And I'll just, we can just use our calculators to simplify this. Again, in our calculators, parentheses, negative 3 over 2 squared plus 3, parentheses, negative 3 over 2 minus 4. Okay, just like that, right? Type the whole thing in. We get negative 6.25. So our vertex is actually negative 3 halves, comma, negative 6.25. That's our actual vertex right there. Okay, and so we'll go over here and we'll graph it. So negative 3 halves is the same as negative 1.5. So there's negative 1, and then negative 1.5 would be halfway, and I'll go down 6. So 1, 2, 3, 4, 5, 6, and then a quarter would be like, right there, we'll say. I'll put my point. Okay. Yeah, if you want to sit at the... You see how they read your name, Samantha?
Yeah.
All right. I guess I'll figure it out.
She was on the phone when she asked me.
Is that a new one?
Yeah,
Have you heard of that?
I've never seen it.
Yes, that's a new one. Okay. All right, let me, yeah. You haven't started the quiz, right?
No.
Okay. There you go. Can you grab the calculator? Do you have one?
Actually, yeah.
Okay. There you go. All right, sorry, folks. So now we're going to make a table, but I'm just going to go ahead and just use my graphing calculator to do the table for us. Okay, so I'll go ahead and type in the x squared plus 3x minus 4. So y equals x squared minus 3x plus 4. Okay, just like that. Oh, plus 3x minus 4. I got my signs mixed up. There you go. Okay, second graph. There's our table. Okay, now that I got my vertex, I can see there's some nice points for us to graph, right? So -2, -6, so -2, -6. And then also -1, -6. Okay, 0, -4, so 1, 2, 3, 4. Okay, and then let's see here, -3, -4. Okay, I'll do a few more here. -4, 0, and 1, 0, so 1, 0. Then -4, 0. Those are easy points. And then I don't think I'll be able to fit the other ones there, so that's good enough. Okay, so again, just using my table here, right? Those are my x and y coordinates, and just applying those points. Get the nice, curve there. Okay, now, at this point, we're going to be a little bit careful. When we graph the inequality, okay, what kind of line should I use when I connect these dots? Should it be solid or a dotted line? When I connect these dots, should it be solid or dotted? Tyler? Dotted. How did you know? Yeah, we don't have the equal to here. Okay, so when we connect these dots on my graph, all right, I don't want it to. I want it to be a dotted line. So as you're drawing, make a dotted line connecting these points. Okay, if it's hard for you to draw a dotted line and connect the points, you can draw a solid line and then just erase, to make it dotted. Okay, but that's important that we draw it. Okay, it's like a borderline for our parabola. So again, when it's just the inequality symbol like that, no equal to, right, dotted line. All right. So how about the shading then? We need to shade as well when we do a problem like this. What inequality symbol is this? Is this greater than or less than? Ooh, it's greater than. It's greater than. Y is greater than x squared plus 3x minus 4. If you have trouble with that, right, if that's something that screws you up or whatever, all right, if you, like back in the day when maybe we're first learning how to determine, to differentiate your left from your right, in life, maybe someone told you a shortcut you could do is to make an L with your hands, in which everyone makes the right capital L, that's your left hand, right? Left L, okay? Well, you can also use that to help you with the inequality symbol here too. That L you make with your left hand, if you just turn it a little bit, that is the less than symbol. Okay? So the greater than symbol goes the opposite direction. The less than symbol is always going to be this way. Okay? So left L with your left hand, turn it, and then there's your less than symbol. So if we want to graph, in this case, this is greater than, right? So this is greater than, so which way should we shade? If I'm on my graph here, and I want to shade greater than this graph, which way should I shade? Above, right? So in other words, it's all this stuff that's on the inside of the graph. Okay? So we'll just shade there on the inside. Okay? I have markers too if you want to use fancy markers instead. I don't want to use markers, I'll put the markers up here. Okay. And that's it. That's all there is to it. That's the graph. All right, so let's try another one here.
How do you do that, your calculator?
There is a way to do it in the calculator. I can show you that here. All right, if you go to y equals, so I already had it typed in. Okay. And so if you, after you typed in your function here, you can actually go all the way over here to the left. So you can arrow over, and you can see that I've highlighted this little section right here. So right now it's gonna just draw a solid line. If I hit enter, it'll toggle through different options. So I now will draw a thicker solid line. Hit enter again. This is going to be the shading above one, Bobby, that I think that we're looking for, right? Because we want to shade greater than, and so this, you can see how it's shaded above and to the right. That means we're going to be shading greater than. If I hit enter one more time, now we'll be shading less than. If I hit enter one more time, I don't really understand what this thing does because it just kind of draws it slower, maybe? I don't know. And then this, I forget what that one does too. And that's a dotted line. Okay.
Mine doesn't do that.
It doesn't. You can't change it.
No, it like just changes the thickness of the line.
And so you can change the. Oh, I might have to look at yours probably because it's a newer one. I'm not sure, but yeah. So there you can see it does the shading then too. So.
Oh,
I don't think mine does the shading either.
It does. Let me see here. Oh, you did the dotted line. That's why. So we got to change it. So that notch right there. That's for greater than. So then. You see
There we go. Yeah, I got
There
it.
we go.
Yeah. Okay. Okay.
Does that affect your table? No, it doesn't.
It doesn't. No. Let's try another one. Okay. Y is less than or equal to negative x squared plus 4. Okay. So for this one, I'm just going to use my graphing calculator because of the interest of time, okay? But we should be able to determine what the vertex is here pretty easily. What transformation, actually, we'll just do this. What transformations do we see here? Okay, so it's a plus 4, but be careful, the plus 4 is not in with the x, it's outside the square. So it's not going to go right 4, it's going to go it's going to be up 4. And then what's that negative in front going to do? It's going to do a reflection over the x-axis, right? So instead of concave up, it'll be concave down, like a frown, okay? So, yeah. So we already know the vertex. It'll be 0, 4 here is the vertex, just from transformations. But let's go ahead and just use our graphing calculators here to help us out too. So, excuse me, negative x squared plus 4. And the y equals there. Go to our table. Okay, and there we can see some nice numbers for us to graph right in there, right? So I'll go ahead over here. Okay, plot our point of 0, 4. So 1, 2, 3, 4. Okay, there's our vertex. And again, just go to your table and your graphing calculator and get some more points here. So negative 1, 3, and 1, 3. Okay, 2, 0, and negative 2, 0. Okay. And then negative, I think I can do 3, 1, 2, 3, 4. Yeah, I drew mine enough so I could like actually do all those. Okay. All right. What kind of line should we use to connect these? Solid or dotted? What kind of line should we use to connect these points? Solid line or dotted line? Look at our inequality here. It's solid because it's got the equal to. Okay. Equal to means we're just including those points that are on the border. Okay. With the not equal to up here, with didn't have an equal to, bless you. Okay, we would not include the points on that as solutions. Okay. Now, what inequality symbol is this? Is that a less than or equal to or greater than or equal to?
Less than or equal to.
Less than or equal to. Again, think about that L, right? It's an L kind of turn on its side there. It's a less than or equal to. So to shade less than or equal to this curve, where am I going to shade? So on the outside would be above the curve, wouldn't it? So it's below. So it's again on the inside, which is weird because in the last one it was greater than and we shaded on the inside. But it was greater than and we shaded on the inside because that was what was above the graph. Here for less than, below this graph is again on the inside of the graph. Okay, what was less than was it was on the inside of the graph.
Are we gonna have a worksheet for a booklet?
It'll be out of the book, yeah. So I can give you more graphic if you need it or something. Okay, so there's that. Okay, so let me have you guys try one here on your own. So here's one for y'all to try. Graph y is less than x squared plus 2x minus 8. Okay, and feel free to use your graphing calculators to help you there with that. I'll leave this one up. So go ahead, try this one. See what you can come up with there. Ooh. That's annoying. Use your graphing calculator to help you with this. Think about what kind of line you're going to use to connect it. Is it going to be solid? It's going to be dotted, okay? And then think about where you're going to shade, too. I'll start getting caught up to you guys. Okay, so there's some of my points. Should I draw a solid line or dotted line to connect these?
Dotted line.
Dotted line, right? And again, what clues us in that it's got to be dotted? No equal to, right? So yeah, dotted line. Okay. And then because it's an inequality, right, you got a shade, because that's indicating where all of our solutions are, where all the solutions are located. So what side of this parabola should I shade on? Should I shade above the parabola, inside, or should I shade below the parabola, outside? Below and outside, because it says less than, right? So all this outside here is what gets shaded. Okay, do not shade on the inside. You're going to be shading on the outside of the parabola. So all of our solutions are outside the parabola there. Okay, something like that. It's like a bearded parabola. All right. I want to show you one more thing here, and I know we're running low on time, and I apologize. It's all that stuff I crammed in at the start of class, but I'll show you one more thing. Okay. And we'll turn the page over here. Okay, so we'll just do it on the back. Okay. Questions on any of that? You can use those graphing calculators to help you. Okay. Does anyone still need a graphing calculator rental form or anything like that? You all getting a hold of one? Okay. You need a graphing calculator rental form? Yeah. Okay. Let me. I need to make another copy of this.
Mr. Witt,
But yes.
the batteries in this calculator are low.
Okay, so if that happens, you'll need to. I mean, so we give you the initial batteries, and then you'll have to replace your own batteries. Okay, it's just AAA.
You need copies, Mr. Witt?
Yeah, I'll
Actually, I don't know.
I'll say it's green if you do. If not, you know what? I can make copies. Maybe at the end of class. Let me just get this problem done real quick, and then I'll get you.
I do still have mine. So
Okay. Sorry. Okay, yeah, just, yep. And again, if a financial problem or whatever, you just don't want to pay it, you know, whatever, write a note, okay, saying it's going to be a financial, you know, strain or whatever kind of thing, and we can get you a free one. Okay? But you got to write the note. All right, anyway, solve x squared minus 2x is greater than 15 algebraically. Okay? So you'll see here there's no y. Just x's, no y's. And notice it does not say to graph it. Now you could actually solve this by graphing, and I'll show you that maybe tomorrow. Okay, but just in the interest of time, I'm going to show you how to do this with algebra. Okay, so what we're going to do is to solve this by hand, we're going to get this into standard form. So in other words, I need to subtract the 15 over, which is, you know, a typical thing that we do. So subtract 15 on both sides, we get that. Okay, and then we're going to factor this. Okay, we're going to factor this. So a times c. Okay, what's our a in this problem? 1. What's our c?
Negative 15.
Negative 15. So ac is negative 15. Okay, we need two numbers that multiply to negative 15 but add to make negative 2. Numbers that multiply negative 15 and add to make negative 2.
Negative 5 and 3.
There you go. Very good. Negative 5 and 3. Very good. So we'll break up that middle term. X squared minus 5x plus 3x minus 15 is greater than 0. Okay, group the first two, group the second two, factor it out, right? So what can we take out of this first group?
An x.
An x. What can we take out of the second group?
3.
Yeah, they both divide by 3.
X plus 3 and x minus 5.
Yep, so it's going to be x plus 3. I'm going to skip this down here. X plus 3 and x minus 5 is greater than 0. So in other words, our zeros here, if I set x plus 3 equal to 0 and x minus 5 equal to 0, we get x is negative 3 and x is 5. But that's not good enough here because we don't have an equation, right? So I use an equal sign here, but we don't have an equation, we have a greater than. How do we take care of this greater than stuff? Because this would only be these would be the solutions if this was all equal signs here. But we're going to use these two numbers that we just came up with, and we're going to create a number line. Okay, and normally with these inequalities, right, graphing a number line is something that you do. I'm going to place these two numbers just kind of randomly on the number line. Just so -3 I'll put right here. And of course, then to the right of it, the 5 should go, right? Because you do want to put them in the right order. -3 then the 5. Okay? So if you look here, we're greater than, no equal to. So at -3, should I have an open circle or a filled in circle?
Open.
Open, because it's not counted, right? Same thing with the 5. Open circle, it's not counted. Okay? And then what we're going to do is we're going to pick numbers in each interval here to test in our inequality. So in other words, what's a number that would be on this side of -3?
-4.
Sure. So let's try -4. Okay? So if I plug -4 in, and you can plug it into the factored version if you want to, or you can plug -4 into the original, or you can plug -4 into this version, whichever one you want. I'll plug it into this because I think it's going to be the easiest to do the math. So -4 plus 3 is -1. -4 minus 5 is -9. -1 times -9, positive 9. Is that greater than 0?
Yeah.
Yes. So that means we have solutions this direction. So all of our solutions are to the left of -3. Now let's pick a number between -3 and 5. What's an easy number between -3 and 5?
0.
Yeah, let's use 0.
0.
Try 0. Okay, so let's plug in 0. 0 plus 3, 3. 0 minus 5, -5. What's 3 times -5?
-15.
Is that greater than 0?
No.
No. So there's no solutions there. Okay, none of these numbers between -3 and 5 are solutions. And so lastly, let's try like 6 here. Okay, so plug in 6. 6 plus 3,
9.
6 minus 5.
1.
So 9 times 1 is 9. Is that greater than 0?
Yes.
Yes. So we get solutions here. So you're going to shade on this side. Okay, just like that. So that's how you're going to be solving those algebraically. Okay. So your assignment. Okay, your assignment. Yes, we are going to have homework. Okay, we didn't quite.
Dang it.
Okay, it's going to be 4 problems. Whoa. Okay. So in the book on.
I knew I would do a better job on this quiz.
Good, good, good.
87 is Houston A.
Can we just do some problems with the 3 guys?
No, I'm not going to do that. Okay, hang on. Okay, sorry, go ahead. You have homework. Okay.
I didn't do 4 of the questions.
Okay, can you need to finish the quiz, you mean?
Oh, I finished it.
Okay, I'll take the quiz. And then just show me the homework tomorrow. Right? Folks, I will post the homework to Schoology, okay? I'm not sure. I have to figure out the page numbers since they're weird. So check Schoology for homework. Check Schoology for homework.